Hello and welcome back to Miss Riley's Maths videos. This is a Leaving Cert ordinary level question on graphing functions, and it's one of a few videos that I'm doing working through some past papers to see how can we pick up marks on these questions, because they can be quite difficult, especially the questions in section B, the longer questions. Now this is question 2. I don't know why. Oh yeah, so this is question 2 on my list, but it's actually paper 1, question 8, and it's just I've gone for D, E, and F because this is a particular graph question. So we're going to quickly look and see how do we do our table. So complete the table below to show the values of, so this is my function, this is my f of x, but they've called it v of x. So v of x and f of x are the same idea, they're both functions, okay, where x is an element of R. Remember, this bit is just telling me the jargon that makes the question true. Basically this means I can join up the dots, and this is telling me this number and this number. Okay, now let's find our table function on our calculator. So mode 3, fill in my function. Now this is quite a long function to fill in. So it's 4, use the alpha button and this button to put in the x to the power of 3. So you've really got to learn to find your way around. Okay, minus 40 alpha x squared plus 100 alpha x, and that's it. There's no constant. Okay, so that was quite hard. Okay, let's go back to 4x cubed minus 40x squared plus 100x. So we're using the alpha button to get the x to put in, and we're using this button for the power. Okay, I then do equals. I don't have a g of x. I don't have a second function. Then I do equals. Where am I starting? I'm starting at 0. Equals. I'm ending at 5. Now this time, do you notice I'm not going up in ones, I'm going up in 0.5, so 0.5. Okay, and that's it. So here's my points. And if I zoom in and focus that in, you should be able to see some of the points. Okay, I'll go back down here. Okay, so what are my points? 0 is 0. 0.5 is 40.5. 1 is 64. 1.5 is 73.5. 2 is 72. 2.5 is 62.5. 3 is 48. 3.5 is 31.5. 4 is 16. 5 is 4.5, and 4.5 is 4.5, and 5 is 0. Okay, so I've just taken those values from this column and put them in the bottom row. Draw the graph of the function. Now this is an x cubed graph. So this is what I call the Loch Ness graphs. Okay, or the camel graphs. That's the shape it's going to be. So let's bear that in mind while we're plotting. So I've got 0 zeros here. I've got 0.5, 40.5. So all these nicer numbers are on the x-axis, and all these horrible numbers are up the y-axis. Because do you notice it goes from 0 to 5, 0 to 5, and 0 to the highest is 72, 73.5, which is way up here. Okay, so 0, that's that one. 0.5, 40.5, so you can only really be approximate. 1 is 64. You can only just guess where these are. 1.5, 73.5, 2, 72, 3, sorry, 2.5, 62.5, 3, 48, 3.5, 31.5, 4, 16, 4.5, 4.5, and 5, 0. So I've just really kind of had to guess. Now you notice it's not quite, it's like this shape here, isn't it? But it's not quite going up. But we don't have to worry. Let's just draw it freehand, no ruler. So you're just drawing in it freehand, and don't do lots of little lines, okay? I made a bit of a mess there. So can I rub that out a bit? I can. Let's just join those two. Okay, so there's my graph. So for those of you that are panicking, there's some marks and there's some marks. If you do those two correctly, you're going to get some marks from those. Okay. Use your graph to estimate each of the following values. In each case, show your work on the graph above. So let's just do a quick reminder. On these, you might be given the x and find the y. In other words, given the input, find the output. You might be given the y and find the x. So given the output, find the input. Okay, those are two basic questions. And then there's the maximum value and the minimum value. So use your graph to estimate each of the following values. In each case, show your work on the graph. The maximum volume. Now, do you notice the maximum we know is up here? The maximum volume. Now, remember volume, they haven't actually said this, but volume is here. Okay, maybe they mentioned volume previously. So volume is here. So when they ask us for the maximum volume, they're looking for the y value at the maximum. So in my graph, I think actually that I've drawn it just slightly, yeah. I think the maximum value is just above this one here. So I'm going to say 74. Okay, is 74, whatever the units are. I don't know what the units are. Maybe they were previously in the question. So what did I do? I went to the top of the graph and I found the y. Okay. The values of x, so values of x, which will create a box which has a volume of 30. So the volume is 30. That means y is 30. So I'm going to go to 30 on my graph. I'm going to go across until I hit the graph. And then I'm going to go down. Okay. So down here and down here. So that looks to me like it's about 0.3 and about 3.55 maybe. Okay. So I'm reading that to be about 3.55, just above 3.5, and that's to be 0.3. Now I think that's a little bit too accurate, but I'm going to just go with it. The volume of the box when x is 2.8. So this is my input. X is equal to 2.8. So I'm going to go to 2.8. Now, I suppose I can use my ruler here to get it. So that's 2, 3, 4. So it's about here, isn't it? 2.8. So let's go up to the graph. And let's go across. So what's that? I reckon that's about 48, is it? Yeah. So about 48 is the volume of the box when my input is 2.8. Okay, so that was going down actually. That was going across and down, up. And sometimes I put in those arrows just to show that I know which direction I'm going. 48. Okay, here's another question. This is question from 2019, paper 1, question 3. It's just another tables function question. So let's use the tables function. So I'm still in mode 3. The function f is defined as this. F of x is equal to minus x cubed plus 4x squared plus x minus 2, where I can join up the dots because x is a real number. The domain, remember, is the inputs from -1 to 4. So that's just telling me what's in the table. And then this just says draw the graph. So all I need to worry about is that's my function and these are my x values. So let's put our function in. So again, it's quite complicated. Minus alpha x cubed plus, now do you notice how I had to use the arrow there? Once I put in my power, if I put plus, it thinks the power is plussing. Okay, but I don't want the power to plus. I want my plus to be down below. Plus 4 alpha x squared plus alpha x minus 2. Okay, equals, that's my function. I don't have a second function, so equals. I'm going to start at -1. I'm going to go up as far as 4, and this time I'm going up in ones. Look, I'm going up in ones each time to get my next value, equals. So now I've got -1, 2, 0, -2, 1, 2, 2, 8. And they always give you one just so you can check you're right. So 10 and then 2. So I've got marks. Can you see those? I've got marks for those. 1, 2, 2, 8, 3, 10, 4, 2. And before 1 was 0, -2, and -1, 2. Okay. Now I've got to plot these. So if you want to, you can list the points if it helps. So -1, 2, 0, -2, 1, 2, 2, 8, 3, 10, and 4, 2. So 0, -2 is there. -1, 2 is here. 1, 2 is here. 2, 8 is here. 3, 10 is here. And 4, 2 is here. Now, did you notice what shape the graph was? Look, it's an x cubed. Remember, x cubed graphs are like the Loch Ness Monster, that kind of wobble. So that looks good, doesn't it? It looks like it's going to be that shape. So I use freehand, and I join, and I join, and I join, just freehand. As long as your graph is reasonably that shape, doesn't matter if there's any little blips. Try and use pencil, because look, I just made a mistake there, and I do this all the time. So use pencil to draw. Look how lovely a shape that is. Now, use your graph to estimate the two roots. Now, roots is a word we normally come across for an equation, the roots of an equation. Okay, so if I have a quadratic equation, okay, this is just an example. If I have a quadratic equation, these are my factors of that equation. Okay, and my roots are -3 and -4. Or if I use my minus b formula, I'd get x. These are roots. These are factors. Now the roots are that if I sub them into the equation, I'd get 0. 9 minus 21 plus 12. Okay, so 0 equals 0. So a root is a number that makes the equation equal to 0. In other words, it makes f of x equals 0, which of course means y equals 0. So when you have the root of an equation, what they're asking you is, where is y equal to 0? Where is f of x equal to 0? But y equals 0 is what makes most sense in our graph, because y equals 0. Now, let's look at this. Y equals 0. Here's y equals 6. Here's y equals 4. Here's y equals 2. Here's y equals 0. So even though there's no 0 written in, there's a 0 now, all along the x-axis. All along the x-axis, y equals 0. So I want to see, where does my curve cut the x-axis? It cuts the x-axis here. It cuts it here. And we don't know where it cuts it over here, so we could ignore that one. So it cuts it here at a kind of, let's see, that would be halfway. That would be minus 0.5. So let's say minus 0.7. Yeah, minus 0.7. X equals minus 0.7. And show it on your graph. You know, you can even do like a root. A root. You can write down cuts the x-axis. So minus 0.7, and let's say that looks at about 0.6. Let's say halfway would be about there, wouldn't it? So that's about 0.6 or 0.7. So I'm going to say 0.6. Oh no, that's maybe 0.7. Let's do that as well. 0.7. Okay, so x equals minus 0.7 and x is equal to plus 0.7. Find the value of x for which f dot dot x is equal to 0. So the second derivative equals 0. Okay, so where f dash x, so where that equals to 0. Okay, so let's think about this because this is now introducing some differentiation. Now, this is a little bit confusing because it doesn't say from the graph. So you'd kind of be so f dash dash x is the second derivative, okay? Which means it's dy dx and then differentiate. My function of x was minus x cubed plus 4x squared plus x minus 2. Differentiate, I normally say dy dx, but when we're doing for f of x, we say f dash x, or at least I say f dash x, that little dash. So I differentiate, and that would give me okay. Remember, we bring the power down in front and reduce the power by 1. And then my second derivative means I differentiate this. So what I have is minus 6x plus 8. Now they're saying find the value of x, setting that equal to 0. So minus 6x plus 8 equals 0. So I'm going to subtract 8 from both sides. Minus 6x is equal to minus 8. Divide by minus 6. Divide by 4 over 3. So that's quite nasty because it's thrown in at the end and it's a differentiation question rather than a graphs question. But that's how we would do it. Okay, I'm going to stop this video.